First of all, I want to say that deviation, this is gonna something is gonna help us for variance. Deviation means how off are you from something. So deviation means how off you are from a number. We're calculating some values. Now our variance, this is going to be equal to the sum. So we're going to be adding the square deviations from the mean. And then we're going to divide it either by n or n minus 1. N is basically going to represent how many numbers do we have in our sample. N minus 1 is obviously how many numbers do we have in our sample minus 1. So variance again is going to be equal to the sum of the square deviations from the mean. Remember, deviation is how off were you. So we're going to have to find the mean. We're going to see how off each of my numbers is from the mean. We're going to square each of those values, and then we're going to add them up. And then we either divide them by n or n minus 1. Now, how are you going to know when do you divide by n or n minus 1? Because I'm going to ask you find the variance of a sample or find the variance of the population. That's actually going to define. We're going to see it more in a minute. We're going to see it more in a minute, but that's basically what variance is. Now, the standard deviation, this is going to be the positive square root of the sample variance. So again, the positive square root of the variance. So we have the variance, just get the square root of the variance, and that's what we call standard deviation. Now range. Now range is how spread are our numbers. What we're going to be looking at is what I'm going to graph here. I'm going to graph something here, but what I'm looking at is our numbers. How far apart are they? Are they going to be all mixed? If I was to draw them, are they just going to be just a loop like this because they're all close to each other? Or are my numbers going to be spread like this? How spread are my numbers? That's what we're going to call range. For us to know how spread are they, what we're going to do is we're going to get the biggest number there is from our list. So the biggest number minus the smallest number. So it's just a simple subtraction. The biggest number minus the smallest number. So that's what we're going to call range. And then you might be wondering, why is that number that important? How is that going to tell me if my numbers are going to be all together in a group or all spread? Because what that means is that if I was to separate this as a number line, and let's say I do equal side spaces, let's say all this are equal sided, equal length. If I was counting by ones, so I was counting by one, how many spaces am I going to need? If I only need like 5 spaces, my information is going to be pretty close to each other. If I need like 200 spaces, my information is pretty spread. But again, we're going to see this more in examples. I leave the spaces there for you guys to be able to write what you guys need. But I'm going to show you an examples for this. Now, for our information, we're going to be using what we call Excel. We're going to be using Excel. You guys can use Google Sheets, but I want to be using this because they are calculators themselves. So this first example, calculate the variance and the standard deviation for the following sample. Very important here. I'm going to emphasize, I'm looking at the sample, okay? We're going to round your answer to the nearest hundredths place if applicable. Okay, hundreds. So because it ends on TH, I know it's a decimal. So because it ends on TH is a decimal. Now hundreds sounds like the number 100. Now, when I think of the number 100, I ask myself, how many zeros are there? And the amount of zeros is going to basically going to tell me how many decimal places my answer will be. Now, 100 has 2 zeros, so hundreds is 2 decimal places. Remember, decimal places is how many digits after the decimal point. So you might be like, oh, that's why when I used to do the nearest 10th was 1 decimal place? Yes, because 10th has 1 zero. 100 has 2 zeros, so 2 decimal places. 1000th, sometimes we might use the nearest 1000th. That's 3 decimal places. So make sure you know how many decimal places. So I'm going to do the variance of a sample, and my answers will be decimal places, 2 decimal places. All right, so let me open an Excel spreadsheet. I'm gonna write the numbers. I'm gonna choose here the numbers that we have for an example. It doesn't really matter where we start. So I'm just gonna start here at the cell B4, okay? So I'm gonna go, my numbers for my example are 49, 42, 43, 32, and 45. So I just picked my numbers, right? And then first thing I'm gonna find out is my mean or average, however you guys want to call it. So what I'm going to do, I'm going to say average. I like to label things. So my average, every time I want Excel or Google Sheets to be a calculator, I want to start with the symbol equals. Once I write equals, I'm basically telling this to be a calculator. So I'm gonna add, I know for an average, I have to add all my numbers here. So let me do sum. Sum, that's how Excel or Sheets know that I'm gonna add. I'm gonna put parentheses. Notice how it's even helping me out. Number 1, number 2. I'm gonna add this number. I'm gonna put a comma. I'm gonna add this number, another comma, this number, and this number. So I'm gonna tell Excel to add these numbers and even label them. You want the cell B4, B5, B6, B7, 8? Yes. So now let me close parentheses. So by that, I already told Excel to stop adding. And then I have to divide. So I'm going to use this right here for dividing, the slash. And I know for average, I have to divide it by how many numbers I have. In this case, I have 5. So let me divide by 5. And press enter. So it's telling me my average is 42.2. Okay, that's the average. I want to find out the deviation for each of my numbers. Remember I said earlier, deviation is how off was each of my numbers. So I'm going to do it up here. I'm going to go equals. I'm going to do 49 minus this average, because I found out the average is 42.2, right? 49 minus 42.2, I press entered, and it tells me 6.8. How off is 49 from the mean? Okay, I press enter and you move to the next cell. Good. So I'm going to go equals. I click on 42 minus the average. I press enter and it tells me how off is each of my numbers from the average. And that's what we call deviation. Now I'm going to do that for each of my numbers. So there. Now 32 minus the average. And then 45 minus the average. I found each deviation. Remember, deviation is how off is each of these numbers from the average. Some of them were positive because they're higher than the average. Some of them were negative because they're less than the average. Now let me square each of these numbers. So square basically means I'm gonna add each of them. I'm gonna multiply each by itself. I'm gonna square them. So here in the next cell, here I'm gonna go equals. I want 6.8 times. Now times, notice I'm using the star. That's on your 8. If you see on your figures on 8, so shift 8, and then press that cell again. So notice how it's telling me C4 times C4, because it's telling me the cell C4 times itself. Good, I multiplied it and then I got the square root of each. Now I'm gonna go C5 times C5 as well. And I'm gonna go 0.8 times 0.8, negative 10.2 times a negative 10.2 became positive. Yes, because when you square a number, it becomes positive. And lastly, 2.8 times 2.8. I squared each of my deviations. Now, I said earlier, variance is going to be the sum of the squared deviations So these are my square deviations. So I'm going to add them up, and then I'm going to either divide by n or n minus 1. So let me just call this sum. And I'm going to do, okay, equals, right? Because I want it as a calculator. This number plus this number plus this number plus this number plus this number. I added, notice how I added my square deviations. Okay, some of you might be lost, like, what did he mean with square deviations? Okay, remember how we had some numbers to begin with? We found the average. And then we found the deviations, is how far each number is from the average. So we found the deviations. I squared each deviation, so we call this the squared deviations. I added the square deviations now. Now, my last thing here for my variance, I'm gonna even write variance. I'm gonna go equals. It is the sum of the square deviations divided by. Now, very interesting thing. There's 5 numbers on our sample, right? So n is equal to 5. I'm gonna divide this either by 5 or 4. If I'm doing the standard deviation of the sample, I'm gonna divide this by n minus 1. And remember, n minus 1 is how many I have. If I'm doing the standard deviation of the population, just divide it by n, just divide it by 5. So in this case, because I'm doing the variance of a sample, let me divide this by 4. And remember the 4, because there's 5 numbers, 5 minus 1 gave me 4. So if my sample had 20 numbers, I'll divide it by 19 because it's 20 minus 1. Okay, so I press that. My variance is going to be 39.7. Awesome. 39.7. That's my variance. But I remembered on the notes it said calculate the variance and the standard deviation. So let me go. I want to go ST for standard, DEV for standard deviation. And I'm going to go equals. I have to get the square root of my variance. You can use a calculator for that if you wish. The variance is 39.7, as you can see. So get the square root of 39.7. Use a calculator. Now, Excel is a calculator, right? For square root here, I'm just going to go SQRT. Open parentheses, and then I click on the 39.7 cell, close my cell, and boom, it tells me my standard deviation is 6.300794. Okay. Let me go back to our nodes here. So I have to find the variance, right? And I have to find my standard deviation. According to our notes, our standard deviation was 39.7. Our variance, I mean, was 39.7. Okay, so my variance is going to be 39.7. Now, I know I ask you, round your answer to the nearest 100th place if applicable. So if you have many numbers, if your answer is many numbers, round it to 2 decimal places only. My case only has 1 decimal number, so I don't need to write it down. Now, some people might be like, Sir Leonzo, I need to have it in 2 decimal places because it says 2 decimal places. Then add another 0. 39.7, 39.70 is the same thing. So because there's the same mathematical value, when you're typing in your homework, if you type in 39.7 or 39.70, keep in mind because they have the same mathematical value, either way is correct. So I wrote down the instructions rounded if applicable. That means if it's only 1 decimal place, you're fine with just 1 decimal place. But if you want to have 2 decimal places, it's fine. Just write it with 2 decimal places. Now my standard deviation, I remembered it was like 6.3007. So I'm just gonna remember it. It was 6.30079369. Some other numbers. I have to have it in two decimal numbers, two decimal places. So I just need to have two. However, when there's more than two decimal numbers, I take a look at the next number. So I'm taking a look at my third decimal number. My third decimal number is too small, and small means 4 or less. If my number is small, I'm just going to ignore it. So my answer in this case will be 6.30. I'm just going to ignore it. My third decimal place is too small. Now, if my third decimal place was big, which is 5 or more, then this 0 would have pushed the previous number. You guys are stat students. You guys know how rounding works, but I'm just going over just for us to make sure we know. Now 6.30. That's fine. Some of you might be, can I just write 6.3? 6.30, 6.3 is the same mathematical value. So fine, you write it how you choose. As long as they have the same mathematical value, you're fine. Good. Now let's take a look at our next question. Calculate the variance and standard deviation. So I'm gonna do pretty similar example. Variance, I have to find out the variance. I have to find out the standard deviation for the following data as a population. Okay, so I have to find it as a population, round to the nearest hundreds. So two decimal places, if applicable. Okay, let me switch again to my spreadsheet. I'm gonna go to Excel. I'm gonna start a new question. So let me erase all this. I wanna erase everything. Doesn't matter where I start. So I'm gonna start here. Let me write the numbers that we have from the list. We have 4, 2, 1, 1, 2. So those are my numbers. Let me find my average. So basically I'm gonna sum. So I'm gonna add all my numbers. So this number plus this number plus this plus this. So I highlight all of them, right? There are other ways on how to highlight. Some of you might be like, I know how to highlight all my numbers at once. I don't want to do that. There are ways. There are ways how to highlight them all. I just don't want us to get too confused if I show too many formulas. I know for my average, I have to add them all and divide it by how many numbers I added. I added 5 numbers. So it seems like my average is 2. Let me find my deviation. So I go here and I go the first numbered minus the average. Well, I forgot to label this, right? I said I like to label. So I'm just gonna say this is my average. Now here, I'm gonna go equals this numbered minus the average. And it's at 0. Yeah, because it was not off, it was right on. Then I go 1 minus the average. This numbered minus the average. And lastly, this numbered minus the average. So I found the deviation of each, basically how off were each numbers from the average. Now here, my next row, remember I have to square each of my deviations. So this number times itself. This number times itself. -1 times -1. Again, -1 times -1. And lastly, 0 times 0. So first I'm gonna add all my numbers. So I'm gonna do this. Remember, you have to start your cell with the equal sign. So you know it's a sum, you're using it as a calculator. I added all my squared deviations. And then lastly, I'm gonna go this number divided by 5. Right now you might be wondering, wait a minute, on the previous question, you divided by 4. Now you're dividing by 5. Okay. The previous question, we were doing the variance of the sample. And remember, we have to divide it by 1 less than the amount we have. So that's why when I was doing the sample, I divided by 4. Now I'm doing the variance of the population. So I do divide it by how many I have. So I divide it by 5, and my variance is going to be 1.2. Let me just write that, variance. So my standard deviation is going to be the square root of that. Again, you can type it in on a calculator, or I'm just going to use Excel, and it tells me it's 1.095445. So, okay. Again, you can use a calculator for this. So let me come back to our notes. My variance, I remembered it was 1.2. My standard deviation, I remember the calculator said 1.09544, and some more numbers. I need to do 2 decimal numbers, but I always take a look at the 3rd decimal number. This number is big enough because 5 is big enough. So the 5 is going to push the previous number. Now do me a favor. Do not call this 1.010, because 1.010 is the same thing as 1.01. So instead of rounding up, you're rounding down by a lot. So it is not 1.010. The thing here is because the 9 is at the limit, this 9 ends up pushing this next number. So my answer should actually be 1.10, not 1.010, okay? The 5 pushed the 9, but because the 9 was at the limit, the 9 ended up pushing the next number up. So 1.09 becomes 1.10, or 1.1, because it's the same mathematical value. Not bad, not bad. Now, when we have n, remember this is how many we have. We have these values. Now, sigma, we talked about sigma before. Sigma basically means that when you're adding things, when I'm adding the x squares, when I added all the x's, we're going to calculate the variance and standard deviation for samples with the following stats. Rounded to the nearest thousandth. Okay, here, 1,000 sounds like the number 1,000. 3 zeros. So that means I want my answer in 3 decimal places. Now for this, for the variance, and I'm going to use this symbol, sigma squared, for variance. For variance, I want us to use this next formula. So I'm going to give you guys your formula. For the next formula, we're going to use sigma of x squared minus, then we're going to do a fraction. In the fraction, I'm going to do sigma of x all squared over n. And all this is going to be a bigger fraction. And at the bottom, I'm going to have n minus 1. So you might be like, whoa, whoa, whoa. Let me show you with our example, my sigma squared, my variance. I'm looking for sigma x squared. So in my case, it's 87. Minus, have a fraction. On top of my fraction, I have sigma x, which is 20 squared over 10. And all this is going to be over 9. See how at the bottom I have n minus 1 because n is 10. So 10 minus 1 is 9. Now, notice on the left side of Canvas, you have what I call calculator. So we're going to use that calculator, okay? Okay, so now I'm going to type it in here. So I remembered, okay, so how did I have this? I remember I had a fraction. So look, I'm going to use this fraction, okay? I'm going to use the fraction, and I remembered that on the top of the fraction, so I'm going to click on the top of the fraction, I had 87 minus, and then there was another fraction on the top. And then on the top of the fraction, I had 20 squared. Look, I'm going to use this key. 20 squared. I'm going to click down at the bottom of the fraction. I had a 10, and at the very bottom, I had a 9. Make sure this looks like how you want it to write. So I highly, highly recommend write it on a piece of paper, right? Notice how my notes, I was writing it. I was writing what I wanted to see. So then I know what to type in on this calculator. So I have 87 minus my fraction on the half, 20 squared over 10, and all of this is divided by 9. My calculator already did the work for me. It says 5.22222 and a bunch of twos. So, okay, so let's take a look. So I'm gonna come back to my notes. My variance, according to my calculator, gave me 5.222 and a bunch of twos. But remember how I have to do it to 3 decimal places? So I have to go to 3 decimal places. The number after it is too small, so I'm gonna ignore it. My answer in this case is gonna be 5.222. My standard deviation is gonna be the square root of that. So I'm gonna do the square root of 5.222. According to my calculator, I'm using a simple calculator. It says 2.28516 and some other numbers. I know I have to do 3 decimal places. The last number is too small, so 1 is, I'm gonna ignore it. My answer in this case is gonna be 2.285. Simple, but I want you guys to start getting used to a calculator. So you guys have a calculator, use it, okay? Now, this last part, the hard part of this thing is basically put them in order. So I'm gonna put this in order. What's the smallest number we have here? In the 30s, right? So we have 31. I'm gonna put this in order. Let me switch this to blue so we don't get confused with the top part. So my numbers are 31, 34, 36, 40, and 43. My range, okay, the range is going to be the biggest numbered minus the smallest numbered. So I'm going 43 minus 31. You might be wondering, do I really need to put them in order? No, not really. You don't. I did just so we could see which one's the smallest, which one's the smallest, which one's the biggest. But if you can see it without putting them in order, then you don't have to. Just go with the big number minus the small number. So 43 minus 31 happens to be 12. My instruction says type an integer to decimal, do not round. So just 12, that's fine. My range is 12. My variance, right? I'm gonna calculate the range, variance, and standard deviation for the following sample. Okay, so I'm gonna go back to Excel, my variance. So let's see. Let me use my calculator, which is Excel. I'm gonna erase all of these. Then I'm gonna start, this time I'm gonna start from this number. My numbers are 36, 43, 40, 34, and 31. I'm gonna have to do the average. And I'm gonna go equals, I'm gonna add all of these numbers. Close parentheses, and then I divide it by 5 because there's 5 numbers. So my average is 36.8. Okay, not bad. I'm gonna find a deviation for each. So 36 minus the average. 43 minus the average. Oops. 40 minus the average. 34 minus the average. And lastly, 31 minus the average. Right, find the deviation of each. Let me square each deviation. So this numbered times itself. 6.2 times itself. 3.2 times itself. Negative 2.8 times itself. And then negative 5.8 times itself. So I'm just going to say sum, because for me to remember, this is just the sum. I'm just adding all of these. Close parentheses. Okay. Now here I have to go equals. My variance is going to be this numbered divided by, because I'm doing of the sample. There's 5 numbers in my sample. So I'm going to divide this by 4. If I was doing this of a population, divided by 5. So I did it from the sample. So my variance, I'm going to label this. My variance is going to be 22.7. My standard deviation, I'm going to label this, is going to be the square root of my variance. So there, we have our answers there. My variance is going to be 22.7, and standard deviation is going to be 4.764452. Okay, so let's go back here. My variance, we said it was 22.7, right? I have to do it to 2 decimal places as needed. Okay, 22.7, 22.7, these the same number. Now my standard deviation, we said it was 4.764452, but here it says round to 1 decimal place. So just 1 decimal place. The next number is big, so this 6 is going to push my number up. So my answer happens to be 4.8. Notice how the range, I asked you for a whole number. Notice the variance, I asked for 2 decimal places, if necessary. And notice for the standard deviation, I asked for 1 decimal place, if necessary. Let's try it one more time. Here, we're going to calculate the range, the variance, and the standard deviation for the following sample, okay? Sample, okay. So first of all, the range. It's easy, right? Which is the biggest number here? 110. Minus, which one's the smallest number? 1. The biggest minus the smallest happens to be 109. Some of you might be wondering, what's the range again? What does this mean? What this mean is, if I was to do a number line here, and I was if I was gonna graph all my information here, I do a little line a little segment to begin with. My range is how many more do I need to do? I will need to do 109 little tags. A lot. Okay. But we just know it's 109 right now. Variance. Okay, let me go back to my Excel. Let me open Excel. I'm going to erase all of these. I'm starting from scratch. So my numbers are 110, 4, 3, 97, 80, 1, 5, 10, and 7. Okay. So first, let me find the average, right? I'm going to add all these numbers. So this, comma, this number, comma. I'm telling it to add all these numbers. And divide this, because I'm finding the average. I found the sum. Notice I closed my parentheses. Divided by how many numbers I added here. There's what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me divide this by 9. And it tells me my average is 35.2. 81, 5, 10, 7. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay. That's my average. Now let me find my deviation. Remember, deviation is equals this number minus the average. Forward minus the average. It makes sense that I get a negative number because 4 is way less than the average. 3 minus the average. 97 minus the average. 80 minus the average. 1 minus the average. 5 minus the average. 10 minus the average. And lastly, 7 minus the average. So I found each deviation. So I have to square each deviation. So the first number times itself. Second number times itself. Times itself. This number times itself. You might be wondering, oh my God, what's happening to all the decimals? Well, good thing we're using Excel because Excel is keeping track of all the decimals. Definitely would not do this by hand. So I'm squaring each deviation. Let me just write sum because I'm just gonna add. Oops. Sum. I'm gonna add all of my numbers here. So this numbered. Notice how I'm separating each of my numbers with a comma. Don't forget that. Close parentheses. Okay. Now here for my variance. I'm gonna go here. Variance and standard deviation. I like to label things. So for my variance, I have to go this divided by. Okay, so there were 9 numbers, right? I added 9 numbers, but because I'm doing the variance of a sample, I have to divide this by 8. So my variance is going to be that 2,117.944. My standard deviation is going to be the square root, open parentheses, of the variance, close parentheses. So again, I'm doing the variance is going to be 2,117.944. Let me come to my notes now. My variance, it is 2,117.944. My instructions said round it to 2 decimal places though. Okay, so 2 decimal places, how many digits after the decimal place? To the decimal point. My third number is too small, so I'm gonna ignore this. So it's gonna be 2,117.94. Let me put the little comma. Do you have to type in the comma? No, you don't. If you do, great. If you don't, great. So my variance is 2,117.94. My standard deviation, according to my calculator, is 46.02 and some more numbers. I have to round it to 1 decimal place. So 1 decimal place. The second decimal place is too small, so I'm going to ignore this. So I'm just going to call this 46.0. If you type in 46.0 or 46, they have the same numerical value, so it is fine. Okay, that's how we do variance.